We will now transition from simple linear regression to multiple linear regression. Let's compare simple and multiple linear regression. The differences between them are highlighted on this slide. Notice that simple linear regression only has one predictor, and multiple linear regression has more than one predictor. In this case, it has exactly two predictors. Here we have our multiple linear regression model. I'll repeat, the only difference between simple linear regression and multiple linear regression is that multiple linear regression uses two or more predictor variables, whereas simple linear regression only uses one. Instead of just using MPG, we are now using a vehicle's MPG and number of cylinders to predict its horsepower. Notice that x2 is a special variable. By now, you should know that x2 is a categorical variable. But more precisely, it is a binary variable, which means it can have exactly two values, no more, no less. The numbers 0 and 1 are arbitrary. They are simply a way of distinguishing between the two groups that the binary variable may represent. They have no numerical significance. Again, they simply help us distinguish whether we are talking about cars with 4 cylinders or cars with 8 cylinders. To derive the meanings of the beta coefficients, we must set up equations for each group or for each value that our binary variable x2 may take. As you can see, for a car with 4 cylinders, x2 is coded as 0. Remember that this number is arbitrary. Plugging in 0 in place of x2, we obtain this equation. For a car with 8 cylinders, we simply plug in 1 into x2, and we obtain this equation. Notice that the only difference between the equation for 4-cylinder cars and the equation for 8-cylinder cars is that beta 2 is added to beta 0. The slope remains the same. In conclusion, even though the intercepts have changed from beta 0 to beta 0 plus beta 2, the slopes are equal for a car with 4 cylinders and a car with 8 cylinders. From the previous slide, we can deduce that beta 0 is the mean horsepower for 4-cylinder cars with average MPG. Beta 1 is the slope for both 8-cylinder and 4-cylinder cars with average MPGs. And beta 2 is the difference in mean horsepower between 8-cylinder cars with average MPG and 4-cylinder cars with average MPG. From running the multiple linear regression function with centered MPG and R, we see that beta 0 is 36.9. This means that the mean horsepower for 4-cylinder cars with average MPG is 36.9. The estimate for beta 1 is -2. Remember that beta 2 represents the slope or change in mean horsepower for both 8 and 4-cylinder cars when average MPG is increased by 1 unit. Putting all this information together, we conclude that the mean horsepower for 8 and 4-cylinder cars decreases by 2 units when average MPG is increased by 1 unit. Finally, the estimate for beta 2 is 12.8. Beta 2 represents the difference in intercepts. This means that the difference in mean horsepower between 8 and 4-cylinder cars with average MPGs is -12.8. In other words, the mean horsepower is 12 units lower for 8-cylinder cars with average MPG than for 4-cylinder cars with average MPG. Now we will transition from multiple linear regression without interaction to multiple linear regression with interaction. The difference between them has been highlighted. The graph on the left has MPG on the x-axis and horsepower on the y-axis. In other words, it shows us the line representing horsepower versus mpg. Not that it would not make sense to graph horsepower versus more than one predictor, as you wouldn't know which is which. The graph on the right also has horsepower versus mpg, but for two different groups, for cars with 4 cylinders and for cars with 8 cylinders. Just from looking at this graph on the right, we know that there is definitely an interaction between mpg and number of cylinders. The difference in slopes tells us that the effect of mpg on horsepower is different for these two groups. Notice how the model with the interaction term does a better job of describing the relationship between mpg and horsepower. From the graph, we see that as mpg increases, horsepower decreases on average. The green line only takes mpg into account. It makes no distinction between number of cylinders. It ignores the fact that the effect of mpg on horsepower changes depending on the number of cylinders. The model with the interaction term does a much better job of accounting for both the very low values of horsepower and the very high horsepower values. This slide may look intimidating, but it is exactly the same thing we've done previously. The equation is only a little bit longer in this case because of the interaction term. Just like before, we calculate the expected horsepower given that x2 is equal to 0 or conditional on a car having 4 cylinders. Again, we plug in 0 into x2 and obtain the following equation. Similarly, we calculate the expected horsepower conditional on a car having 8 cylinders. In this case, we plug in 1 into x2, and we obtain this equation. Notice that in this case, both the intercepts and the slopes have changed. The intercept changes from beta 0 to beta 0 plus beta 2, and the slope changes from beta 1 to beta 1 plus beta 3. For this particular model, it is helpful to think in terms of a baseline group. The baseline group is the group for which all the independent variables are equal to 0. Let's imagine for a moment that we have mpg uncentered, just so you understand the concept of baseline groups. So in the uncentered case, the baseline would be the group in which mpg is 0 and x2 is 0. In other words, 4-cylinder cars with 0 mpg. However, since mpg is centered, the baseline group consists of cars with average mpg and with 4 cylinders, or when x2 is equal to 0. Once again, we can deduce from the previous slide that our baseline group consists of 4-cylinder cars with average mpg. Beta 0 is the mean horsepower for the baseline. Beta 1 is the slope for the baseline. Beta 2 is the difference in intercepts between 8-cylinder and 4-cylinder cars with average mpgs. Finally, beta 3 is the difference in slopes between 8 and 4-cylinder cars with average mpgs. From the R output, we see that the estimate for beta 0 is 68.4. This tells us that the mean horsepower for the baseline group, that is, for 4-cylinder cars with average mpg, is 68.4. The estimate for beta 1 is 2.8. This tells us that the slope for 4-cylinder cars with average mpg is 2.8. In other words, the mean horsepower increases by 2.8 units when we increase average mpg by 1 unit. The estimate for beta 2 is 4.3. This means that the mean horsepower is 4.3 units higher for 8-cylinder cars with average mpg than for 4-cylinder cars with average mpg. Lastly, the estimate for beta 3 is negative 1.1, meaning that the slope or mean change in horsepower is 1.1 units lower for 8-cylinder cars than for 4-cylinder cars when MPG is increased by 1 unit. And that is it for this video. I hope you enjoyed it. In the next video, Yamini will explain the assumptions for multiple linear regression with interaction, and we will check whether our model meets those assumptions. See you soon.